Welcome, everyone, to today's deep dive right here on the Bite-Sized Tech News TLDR. I'm just so incredibly pumped to be sitting down with you today.
Yeah, it is. It's great to be here.
Now, if you are a regular listener or if you watch our daily videos on the YouTube channel, we normally bring you a pretty rapid-fire roundup.
Right, the usual daily news hit.
Exactly. We cover a dozen stories across the whole tech landscape, give you the quick hits, and get you on your way. But today's different.
Very different.
We are absolutely not doing a standard news roundup today. We're doing an urgent, just fast-paced, highly targeted deep dive into one single source of information that just dropped.
And it really demanded its own dedicated session.
Oh, totally. Frankly, this piece of news is so massive, so disruptive to how you're going to work tomorrow that we just had to do this.
We did.
So our mission today is crystal clear. We are going straight to the bottom line to unpack Anthropic's massive new update, which is Claude Opus 4.6. We're going to cut through all the marketing noise, eliminate all the fluff, and just explain exactly what this means for your immediate real-world productivity and your security, too.
Yeah, the security aspect is huge here.
It really is. So, look, if you're a professional, whether you're in finance or law or coding or really just trying to navigate this crazy tech landscape without getting completely overwhelmed by information overload, you were in the exact right place.
I think your framing is absolutely critical today.
Yeah.
Because the pace of information right now is just relentless.
Exhausting.
It is. It's very easy for you, the listener, to get lost in the marketing hype whenever, a new artificial intelligence model drops. Every company claims they've revolutionized the industry every other week.
Oh, we see it literally every Tuesday.
Exactly. But the underlying mechanics of what Anthropic has just released with Opus 4.6, it represents something different.
Right.
This isn't just some iterative update where it generates text a little bit faster. We are looking at a fundamental paradigm shift.
A little shift.
We're looking at a transition that completely redefines how professionals interact with digital systems from the ground up.
I love that you use the phrase paradigm shift, because when you look at the source material Anthropic just put out, and they're not being shy about this, by the way, they brought the receipts,
They definitely brought the data.
they brought the benchmarks, the data, all of it. There is one core driving question behind the entire development of Opus 4.6.
Right.
And that question is, what if AI felt less like a fragile tool that you have to constantly guide, and more like a highly capable, completely trusted collaborator?
That's the key distinction.
Because think about the tools you use right now.
Right.
A hammer is a tool. It doesn't know you're building a house. It just hits the nail when you swing it.
Right. And if you swing it wrong, the nail bends.
Exactly. The nail bends. And up until now, AI has largely been a really fancy hammer.
Very fancy, but still a hammer.
Right. You have to constantly handhold it, give it the exact perfect prompt, check its work, and correct it when it inevitably goes totally off the rails.
Which it always does eventually.
It always does. But Anthropic is claiming they have moved past the hammer. They are claiming they have built a colleague.
A true collaborator.
Yeah. We're talking about the difference between a tool you micromanage and a team member you actually trust to handle complex, high-stakes work entirely on their own. Okay, let's unpack this.
Let's do it.
Because to really grasp how they've turned a fragile tool into a true collaborator, we have to look at the raw intelligence numbers.
Right, the actual benchmarks.
And the stats they are claiming in this release are just off the charts. But I want to make sure we're actually looking at the right numbers here.
Good point.
Because we've all seen AI models ace the SATs or, pass the bar exam and then completely fail to format a basic spreadsheet.
That is the exact trap so many people fall into.
Yeah.
When we look at the data provided in this release, Anthropic is making the explicit claim that Opus 4.6 is now the industry leader, full stop.
Period.
But what is absolutely crucial for you, the listener, to understand is how they are measuring this dominance. They aren't just using the standard, older tests that measure basic trivia recall.
Right, no high school biology question.
Exactly, or standardized testing capabilities. They're pointing to a specific, highly rigorous benchmark called GDP-Val.
Right, and the source material leans heavily on this GDP-Val benchmark. So for anyone who isn't a machine learning researcher, what exactly is this test doing that makes it so much more credible than the older ones?
It comes down to the nature of the tasks being evaluated.
Okay.
GDP-Val stands apart because it's specifically designed to measure how well an artificial intelligence handles complex, real-world knowledge work.
Real world being the operative phrase.
Exactly. We aren't talking about asking the AI to write a poem or summarize a Wikipedia article. We're talking about highly specialized, rigorous fields: corporate finance, enterprise data analysis, legal contract review.
Heavy hitters.
These are domains where the concept of being mostly right is fundamentally unacceptable.
Yeah, mostly right gets you fired.
Exactly. If a junior analyst is mostly right about a merger arbitrage calculation, the firm loses millions of dollars.
Or if a paralegal is mostly right about an indemnification clause in a vendor contract, the company is suddenly exposed to massive liability.
Precisely. The GDP-Valal benchmark explicitly tests the system's ability to navigate the kind of complex, high-stakes, multi-step environments that you, as a professional, operate in every single day.
It's testing the real grind.
It tests reasoning, logic, constraints, and the ability to synthesize disparate pieces of dense information without hallucinating.
And the way they score this GDP Valal benchmark is absolutely fascinating.
It's very unique.
The source notes that they don't just give it a percentage grade like a high school math test. They use the L rating system.
Right.
Now, if you're a chess fan, or honestly, if you play competitive video games, you probably know exactly what this is.
The ELO rating.
Exactly. It's essentially the exact same statistical ranking system they use to evaluate and rank chess players against each other. It's not just a score out of 100.
No, it's relative.
Right. It calculates the mathematical probability of one player, or in this case, one AI model outperforming another in head-to-head complex problem solving. It's completely dynamic.
Precisely. The L-based rating system is designed to measure relative skill. If an AI model successfully completes a complex reasoning task that another model fails, its rating goes up and the others goes down.
It's a zero-sum game.
It creates a highly accurate hierarchy of capability based on direct head-to-head performance on these really grueling professional tasks.
And the numbers they're reporting here are just staggering. According to the release, Opus 4.6 achieved a 190-point jump over its own predecessor.
Which is massive on its own.
Massive. But the real headline, the thing that is making waves across the entire industry today, is its position against the competition.
Right.
It holds a commanding 144-point lead over its main rival, GPT 5.2.
A huge margin.
Now, I want to play devil's advocate for a second here.
Move for it.
A 144-point lead sounds like a really big number on a press release. But if I'm just a regular person using this to draft emails or analyze a market trend, does a 144-point gap on a chess-style leaderboard actually translate to a noticeable difference in my workday?
It translates to an entirely different tier of reliability.
Really?
Yes. In any L-based rating system, a gap of that magnitude isn't just a narrow incremental win. It indicates that in complex, multi-step tasks, the higher-rated system is going to successfully resolve the problem with vastly superior consistency.
Okay.
To put it in human terms, a 144-point lead in a chess ranking means the higher-rated player is going to win the vast majority of the time.
It's a blowout.
It is a grandmaster playing against a local club champion.
Wow.
So when you apply that statistical dominance to real-world knowledge work, it means that while the rival model might get confused by step 4 of a 10-step financial analysis, Opus 4.6 will complete all 10 steps flawlessly, almost every time.
That consistency is everything.
It is. It's a massive statistical gulf that directly impacts how much you can actually trust the output. What's fascinating here is how broad that dominance really is.
Yes, that is a great point. It is not a one-trick pony at all.
Not even close.
The source explicitly highlights that Opus 4.6 is ranking #1 across a wide variety of incredibly tough, highly distinct benchmarks. Let's talk about agentic coding, for example.
Right, this is a big one.
Because the source makes a huge deal out of this.
Yep.
Now, we've had AI that can write code for a while.
Sure.
You ask it for a Python script, it spits one out. But this agentic coding sounds fundamentally different. How does the source differentiate what Opus 4.6 is doing from the code generators we were all using 6 months ago?
The difference really lies in autonomy and the feedback loop.
Autonomy.
Yes. With older models, like you mentioned, you provide a prompt and it generates a static block of code.
Right.
You then have to take that code, copy it into your own development environment, run it, and see if it actually works.
And spoiler alert, it usually throws an error.
It often does, perhaps because of a missing dependency or a logic flaw. Then you have to copy that error message, paste it back into the AI, and ask it to fix its own mistake.
Right. You are the manager actively supervising a rather incompetent intern.
Exactly. Agentic coding, which Opus 4.6 just completely dominates and removes you from that loop almost entirely.
So what does that actually look like in practice for a developer?
It means the AI literally writes its own code, spins up a secure environment, executes that code, monitors the output, finds its own bugs, reads the stack trace, and then debugs that code independently before ever showing it to you.
Before I even see it.
Yes. It is doing the work of an entire engineering loop.
That's crazy.
If you asked it to build a data scraper for a specific website, and the website's structure has changed slightly, an older model would just fail. Opus 4.6 will write the scraper, test it, realize the HTML tags don't match, autonomously inspect the new website structure, rewrite its own code to adapt to the new tags, test it again, verify the data is being extracted correctly, and then present you with the final working product.
So it's an autonomous agent, not just a text generator.
Precisely.
That is just wild. It's essentially iterating on its own failures at computer speed. And the source points out that this kind of autonomy isn't just restricted to coding.
Right.
It's dominating in complex, multidisciplinary reasoning. Plus, it is taking the #1 spot for extracting hard-to-find information online.
Which is huge for research.
Huge. We all know how frustrating it is to search for that one buried white paper or that specific regulatory data point hidden across a dozen different government websites.
You can spend hours just tweaking your Google search term.
Exactly. But Opus 4.6 has taken the top spot across the board in all of these distinct areas: coding, logic, deep research.
Which brings us to the most critical point for you, the listener.
Right, the bottom line.
Why does a 144-point lead on a complex knowledge work benchmark and top-tier scores in agentic coding and reasoning matter to you on a Tuesday morning at the office?
Good question.
It matters because this commanding lead signifies a very specific threshold being crossed in the evolution of artificial intelligence.
Okay.
For a long time, using AI in professional settings meant prompting it for a single, isolated task.
Right.
You ask it to summarize a single email. You ask it to draft a single paragraph. You ask it to translate one document. It was microtasking.
It's just tiny little jobs.
But with this level of sustained, multidisciplinary intelligence, professionals can now confidently hand off complex, multi-step workflows.
You're delegating now.
You are no longer managing microtasks.
Yeah.
You are delegating comprehensive projects.
So instead of asking it to just summarize this article on battery tech, I could ask it to research the latest battery technology trends, analyze the potential financial implications for the electric vehicle sector over the next 5 years, write a Python script to model the projected material costs based on current commodity prices, and format all of those findings into an executive brief.
Exactly.
That's one single prompt, but it requires research, financial reasoning, coding, and synthesis.
You are outlining a delegated workflow that spans multiple professional disciplines. And for that kind of complex delegation to actually work, the system has to maintain its focus, its reasoning, and its intelligence over a very long period.
It can't lose the thread.
Right. It has to remember the initial goal of the executive brief while it is deep in the weeds of debugging the Python script for the material costs. And historically, maintaining that cohesive intelligence over long, complex tasks has been a massive, debilitating vulnerability for these models.
I am so glad you brought that up, because it perfectly bridges us into the next major revelation from the source material. We have to talk about a concept that developers call context rot.
Ah, yes, context rot.
Now, for anyone who hasn't heard that term before, I guarantee you have experienced it if you've ever tried using AI for a big project.
Absolutely.
Let me give you a real-world example. Last year, I had this massive 50-page vendor contract I needed to review.
Mm-hmm.
Dense legalese.
The worst kind.
The absolute worst. I fed the whole thing into one of the top AI models at the time and gave it a very specific set of instructions on what to look for regarding intellectual property rights.
Okay.
For the first few pages, it was brilliant. It was pulling out great insights. But by the time I was asking it questions about page 40 or 45, it was like dealing with a completely different system.
You just degrade it.
Completely degraded. It had completely forgotten the instructions I gave it at the beginning. It forgot who the buyer and the seller were. Its reasoning got muddy. It started hallucinating clauses that didn't exist. It had essentially lost the plot.
That is the textbook definition.
Yeah. That degradation of performance, that forgetting, is context rot.
It is an incredibly frustrating phenomenon, and it happens because of how the underlying architecture, the The attention mechanism of these older models handles information over time.
Okay, break that down for us.
As you feed it more and more data, its attention literally gets diluted. It becomes overwhelmed by the sheer volume of text, and the earliest instructions or data points you provided simply get pushed out of its effective reasoning capabilities.
It rots.
It rots. But the source material makes it unequivocally clear that Anthropic has tackled this problem head-on with Opus 4.6. They've deployed a massive, and I mean an unprecedentedly massive memory upgrade.
Yes, they are touting this massive new memory capacity. But before we get into the stats, I think we need to clarify some of the jargon for everyone tuning in.
Always a good idea.
Because the tech industry throws these terms around, assuming everyone is a back-end developer.
Very true.
The source says Opus 4.6 has a 1 million token context window. Let's break that down. What exactly is a token? And what is a context window in plain English?
That is a crucial clarification. Let's start with a token. You can think of a token as a fragment of a word.
Okay.
A good rule of thumb is that one token is roughly 3/4 of a standard English word. So it isn't measuring exact word count, but it is a close approximation.
Right.
Now, the context window is the model's active working memory. It is the amount of information, the number of tokens that the AI can hold in its brain and consider simultaneously at any given moment while it is generating a response.
It's the immediate workspace.
Exactly.
So if a token is about 3/4 of a word, a 1 million token context window means this AI can hold roughly 750,000 words in its active memory at the exact same time.
That's the math.
Just to give you a sense of scale on that, the average novel is about 80,000 words. So we were talking about the ability to ingest and actively remember 9 or 10 entire books simultaneously.
Which is staggering.
You could feed it the entire Harry Potter series in one go, ask it a highly specific question about a minor character in book 1 while referencing an event in book 7, and it has all of that text readily available in its active memory.
That is the exact scale we are dealing with here. It is an astronomically large cognitive workspace.
It's huge.
And it is engineered specifically so the model can maintain peak performance, peak reasoning, and peak intelligence, even when you subject it to incredibly long, dense, and complex jobs.
Like my 50-page contract.
Exactly. The goal is to fundamentally alter what you can input into the system. Entire code bases, years of financial records, massive legal repositories. You can put it all in without the fear of the system losing track of the details or succumbing to that context rot you experienced.
But having a huge memory bank is only useful if you can actually find the information you stored in it, right?
Right. Recall is just as important as capacity.
Because I have a massive hard drive on my computer, but half the time I can't find the file I'm looking for. To prove that this 1 million token window isn't just a marketing gimmick, the source material details a specific evaluation they ran called the needle in a haystack test.
A classic benchmark.
And I love this test because it is so beautifully simple to understand. It is exactly what it sounds like. They take a mountain of text, a full 1 million tokens of dense, distracting, irrelevant data, and they intentionally bury one tiny, highly specific fact somewhere deep inside it.
That is the needle.
That is the needle. Then they ask the AI a question that requires it to find that one specific needle in the haystack.
It is the ultimate test of retrieval accuracy within a massive context window. It proves whether the model is actually reading and retaining the information or just skimming and losing focus.
And the results the source is claiming here are absolutely wild. Opus 4.6 scored an incredible 76% on this needle in the haystack test.
Very impressive.
Now, hold on, because I know what some of you are thinking. I'm going to play the skeptic again.
Please do.
If my kid comes home with a 76% on a math test, that is a solid C. It means they got a quarter of the questions wrong.
True.
If I'm a lawyer and I use this tool to find a critical liability clause in a massive discovery dump and it has a 24% chance of missing it, I'm getting hit with a malpractice suit. How is a 76% success rate being touted as a revolutionary breakthrough?
It is a completely fair question, and context is everything here. First, we have to look at what it is being compared against.
Okay.
The source notes that the previous state-of-the-art model scored just 18.5% on this exact same test.
Wow, 18.5%.
Yeah.
So the previous model was basically just guessing or completely lost in the noise.
Exactly. An 18.5% recall rate essentially makes a tool professionally unreliable for large data sets. You simply cannot trust it.
No way.
Going from 18.5% to 76% isn't just a minor iterative software update. It is a fundamental architectural breakthrough in how the attention mechanisms retain fidelity over massive spans of data.
It's a massive leap.
But secondly, And more importantly, for your legal malpractice hypothetical, we have to understand what the needle in a haystack test is actually designed to do.
Okay.
It's an extreme stress test. It is designed to be artificially difficult.
How so?
It buries a single, completely out-of-context sentence inside a million tokens of entirely unrelated text. It is looking for a glitch in the matrix.
Oh, I see.
In real-world professional applications, like your legal discovery example, the information you are looking for isn't a random out-of-context sentence. It is thematically linked to the surrounding text.
Right. Contracts have structures, headings, and logical flow. Financial reports have tables of contents and standardized formatting.
Precisely. When you apply this new architectural memory to structured, real-world data, the practical retrieval rate for relevant information is effectively near perfect. The 76% score on the extreme stress test is the raw proof of that underlying capability.
Okay, that makes perfect sense. It's like testing a sports car in a wind tunnel versus driving it on the highway. The wind tunnel is extreme, but it proves the aerodynamics work in the real world.
Great analogy.
So when we take that extreme capability and apply it to a Tuesday afternoon, the real-world impact is completely game-changing.
It really is.
If you are a financial analyst trying to reconcile massive data sets spanning multiple quarters, or if you are that legal professional who needs to parse through hundreds of pages of dense case law, this is revolutionary.
Because the AI isn't just skimming anymore.
Right. It is no longer just skimming for keywords and hoping for the best. It is actively retaining the entirety of the document. Like my vendor contract example from earlier. With Opus 4.6, it won't forget the indemnification clause on page 2 by the time it reaches the signature block on page 50.
It holds the entire logical structure in its working memory.
This makes analyzing massive, complex professional documents truly viable in a way it simply wasn't before. Here's where it gets really interesting.
Oh, we're just getting started.
Because Anthropic didn't just stop at making the AI smarter and giving it a bigger memory. They didn't just build a better brain. They completely, fundamentally redesigned how that brain actually approaches a problem.
The architecture itself.
Yes. To illustrate this shift, the source included a quote from one of Anthropic's early partners over at Notion, the productivity software company. And this quote just perfectly captures what they are trying to achieve here.
It's a great quote.
The Notion partner says that this update isn't just about building a better tool. It is about changing the entire relationship we have with AI, moving it away from a command line interface and towards real, genuine collaboration.
It is a profound shift in design philosophy. And the technical feature that actually makes this genuine collaboration possible, the architecture underlying this shift, is something Anthropic is calling agent teams.
Agent teams. It sounds like something out of a sci-fi movie.
It really does.
But the source material breaks it down in a very practical way. To understand why agent teams are such a big deal, we have to understand how AI used to work. You mentioned earlier that older models were linear. What does that actually mean when I give an AI a prompt?
Historically, large language models have operated sequentially or linearly. They process information and generate output step by step, one token at a time.
Okay.
It is a very single-minded process. Imagine a kitchen with only one chef.
I like this analogy. Let's go with the kitchen.
Okay, so if you order a complex meal, that single chef has to chop the onions, finish chopping them, turn on the stove, wait for the water to boil, cook the pasta, finish the pasta, and then start making the sauce.
They can only do one thing at a time.
Right. If you give a linear AI a complex problem, it has to work through part A, finish it entirely, move to part B, finish it entirely, and so on. It is a massive bottleneck of compute.
So it's slow.
Very. But agent teams introduce the concept of parallel processing into the AI's workflow.
So sticking with the kitchen analogy, instead of one chef doing everything sequentially, parallel processing means you have an executive chef who reads the ticket and immediately spins up a sous chef to chop the onions, a line cook to boil the pasta, and a prep cook to make the sauce, and they're all working at the exact same time.
That is precisely it. Instead of a single AI working linearly, you effectively have a whole team of specialized subagents that are spawned autonomously to work on different facets of your complex problem
So
simultaneously.
they operate in parallel.
Yes, and crucially, they coordinate with each other autonomously to reach a solution significantly faster and with much higher fidelity.
I love how the source material actually breaks down the mechanics of this. They outline the 4 key stages of this advanced agentic thinking workflow.
It's a very clear process.
Let's walk through them right now, because this is exactly what is happening under the hood when you hand off a major project to Opus 4.6. Let's say I'm a marketing director, and I need a comprehensive Q3 competitive analysis based on a mountain of raw data, web trends, and internal sales figures. Stage 1 of the agent team workflow is planning.
The crucial first step.
Before it even writes a single word or starts pulling data, the model looks at that big, overwhelming task I just gave it. What does it do next?
In the planning stage, the AI acts as that executive chef. It doesn't just start blindly generating text. It autonomously breaks that massive, complex task down into smaller, highly manageable modular pieces.
Okay.
It analyzes the constraints of your prompt. It recognizes that to build a Q3 competitive analysis, it needs to first structure a data ingestion plan, then formulate a web scraping strategy for competitor pricing, then design a statistical comparison model for the internal sales figures.
It creates its own project roadmap entirely independently.
Exactly. It builds its own internal Jira board.
And that planning phase is exactly what enables stage 2, which is execution. Because the big task is now modularized into smaller pieces, the system doesn't have to work linearly anymore.
Right. It can deploy the team.
It can spin up those multiple sub-agents and execute various tools all at once, in parallel. While one agent is out gathering the web data on competitor pricing, another agent is simultaneously drafting the structural outline for the final report, and a third agent is running statistical models on the internal sales figures.
They're all working concurrently.
But, as anyone who has ever managed a real project knows, things never go perfectly according to plan. APIs fail. Data is formatted weirdly. Websites block scrapers.
Roadblocks are inevitable.
Which brings us to the third stage, and honestly, this is the one that blows my mind the most. Troubleshooting. In the past, if an AI hit a roadblock, it just stopped and threw an error message at you. How does an agent team handle a roadblock?
This is where the autonomy truly shines. Let's say the subagent tasked with scraping competitor pricing hits a paywall or a broken link.
Typical problem.
In a linear model, the entire process halts. You get an error message and you have to intervene. But with Opus 4.6, the system is capable of identifying these roadblocks with real precision mid-task.
So it knows it failed.
Yes. The subagent recognizes the failure, communicates the error back to the central planning logic, and the agents coordinate to pivot.
Wait, it pivots on its own?
On its own. The system might autonomously decide to search for alternative public pricing sheets or utilize a different search API to find the data. It formulates a new hypothesis, tests a new approach, and resolves the issue, all without ever needing to stop and ask you, the human user, for a new set of instructions.
It just figures it out.
It figures it out.
It is actively problem-solving its own failures. That is incredible. And then finally, we reach stage 4, which is synthesis.
Bringing it all together.
Right. After all these parallel agents have done their planning, executed their parallel tasks, and troubleshooted their own roadblocks, the central system pulls all of those disparate threads back together.
The executive chef plating the meal.
Yes. It takes the web data, the statistical models, the structural outline, and merges them into one cohesive, highly polished, final output. It hands me my complete Q3 competitive analysis.
It's a complete shift in workflow.
When you look at those 4 stages, planning, execution, troubleshooting, and synthesis, the productivity bottom line here for you, the listener, is just staggering. It drastically, and I mean drastically, reduces the amount of manual hand-holding and constant prompting that professionals used to have to do.
You aren't micromanaging the individual steps anymore?
No, you are managing the final outcome.
Precisely. You are shifting from being an operator of a machine to being a manager of an incredibly capable digital team. You set the strategic goal, you provide the raw materials, and you review the final synthesis.
The execution layer is handled autonomously.
Completely autonomously. And to facilitate this entirely new dynamic, Anthropic hasn't just released a consumer chat interface. They have provided robust, highly technical mechanisms to control exactly how this massive intelligence is deployed.
Yes, the source material goes deep into the tools they're giving to developers to manage this beast. Because when you have a system that can spin up autonomous sub-agents and think for itself, you need granular control over how much computing power it is allowed to use.
You have to manage the resources.
Exactly. Let's talk about the developer controls for a minute. The source details a whole new suite of controls built directly into the API. First up, they mention something called adaptive thinking. What is that?
Adaptive thinking is a brilliant economic and functional control. When you query an AI model, every token generated costs computational power, which equates to real-world money.
Right, compute isn't free.
Exactly. If you ask a model a simple question like, what is the capital of France? You don't need it to spin up a massive, complex reasoning chain. You just want the answer quickly and cheaply.
Paris. Done.
Right. But if you ask it to debug a complex cryptography script, you want it to spend time reasoning through the logic. Adaptive thinking allows the model itself to dynamically decide, based on the complexity of your prompt, when a problem requires deeper, more intensive compute resources versus when it can be solved quickly with standard processing.
So it scales its own effort.
It automatically scales its own brain power to match the difficulty of the task.
That makes a ton of sense. It's like, I don't need my senior engineer to spend 4 hours optimizing a basic HTML button, but I absolutely want them spending 4 days architecting the database backend. It dynamically allocates the necessary effort.
Exactly.
And the source also highlights effort controls, which seems to be the manual override for that adaptive thinking.
It is.
It gives developers the granular ability to manually balance peak performance against operational costs. If I'm building an app that just categorizes customer service emails, I can dial down the effort to save money.
Right.
If I'm building a medical diagnostic assistant, I can dial the effort up to maximum to ensure the highest possible reasoning fidelity, regardless of the compute cost.
Exactly. It provides the necessary economic levers for businesses to integrate this technology sustainably. And alongside that, they have introduced a feature called context compaction.
I was just about to bring that up. Context compaction. Now, if I'm a regular user, I'm never going to see a button that says compact context. But why should I, as an everyday professional using an app powered by Opus 4.6, care that developers have this feature?
Because it is the reason your application won't crash or slow to a crawl when you are working on a massive long-term project.
Ah, okay.
We discussed the 1 million token context window earlier, the ability to hold massive amounts of data in active memory. But rereading 1 million tokens every single time you ask a follow-up question is computationally heavy and very slow.
I can imagine.
Context compaction is a back-end feature that allows developers to take that massive long-running chat history or that huge ingested data set and compress the core relevant knowledge into a denser, more efficient format.
So it optimizes the memory.
It means that when you are on day 3 of analyzing a massive financial data set, the system remains lightning fast and highly responsive because it isn't wasting time unnecessarily reprocessing the entire raw data feed on every single query.
It is making the heavy lifting invisible to the end user. That is brilliant. And speaking of the API, for all the devs out there listening who are itching to plug this into their backend right this second, the source dropped the magic API string you need.
It's ready to go.
It is fully live. If you want to call this specific model in your code, the string is simply Claude Opus 4.6. Just plug that into your API calls, and you are off to the races with everything we just talked about.
It's that simple.
But while the developer controls are incredible, we have to pivot right now to what I think is the absolute most exciting part of this entire release for the vast majority of professionals tuning in.
The everyday integrations.
Yes. Because if you were listening to this and thinking, well, I'm not a back-end developer, I don't know what an API call is, I just work in marketing or finance, do not tune out.
Definitely do not tune out.
These upgrades are absolutely not just for coders. Anthropic is bringing this massive intelligence directly to the everyday work tools that non-coders are already using right now.
This is where the theoretical benchmarks and the API controls translate into immediate, practical, day-to-day utility.
It's the real-world application.
Exactly. The integration of Opus 4.6 into standard enterprise software is profound, and it is going to change how millions of people execute their daily tasks. The source material specifically highlights the upgrades coming to Claude integrated within Excel.
Excel, the lifeblood of corporate America.
The operating system of business.
We all live in spreadsheets. But let's be honest, data analysis in Excel can be an absolute nightmare. I know people who spend half their week just cleaning up messy CSV exports from legacy software.
Oh, the manual data wrangling.
It's the worst. The dates are formatted wrong, the names are combined in one column, the numbers have weird symbols attached to them. It is unstructured, messy data. How is Opus 4.6 changing the Excel experience?
It is effectively acting as a senior data analyst sitting right inside your spreadsheet. Excel is the backbone of global corporate finance and data management. With this update, Claude in Excel is no longer just helping you write basic SUMIF formulas. It can handle significantly harder multi-step data analysis autonomously.
So it goes beyond basic math.
Way beyond.
Right.
Let's take your example of the messy CSV export. Previously, you would have to manually write complex macros or use text to columns or painstakingly write regex functions to clean that data before you could even begin to analyze it.
Hours of work.
Now, you can simply highlight the unstructured, messy data and instruct the AI to structure this data for a Q3 revenue analysis.
And it just does it.
It just does it. It uses its advanced reasoning capabilities, that GDP val intelligence we discussed, to intuitively understand the context of the messy data.
That's amazing.
It recognizes the misaligned dates, it identifies the anomalous characters, and it autonomously restructures, cleans, and formats the data into a usable table without requiring you to hold its hand or write a single line of macro code.
Just from highlighting and asking.
And once it is structured, you can use those agent teams to execute complex, multi-step financial models directly on that clean data.
That is an absolute lifesaver. Gives me anxiety just thinking about those messy spreadsheets.
Yeah.
But as amazing as the Excel integration is, the one that really blew my mind from the source material is the preview they showed for Claude integrated into PowerPoint.
Oh, this is a game changer for presentations.
It really is. Now, I have to make a lot of presentations, and there is nothing more terrifying than a blank white PowerPoint slide when you have a massive Word document full of ideas that you need to present to a client in an hour.
The blank page syndrome.
It's real. Translating dense text into an engaging, visually appealing presentation is a massive time sink.
It is a fundamentally different skill set. Writing a comprehensive report requires deep analytical thought. Building a presentation requires synthesis, pacing, and visual communication.
Exactly. And according to the breakdown in the source, Opus 4.6 bridges that gap completely. This is not just an AI adding a few generic bullet points to a slide.
Well, it's comprehensive.
You can take that massive Word document, say a 20-page strategic roadmap, feed it into the system, and provide a simple text description of what you need. You just say, turn this strategic roadmap into a 15-minute executive presentation.
And it builds the whole thing.
Claude will generate an entire, fully fleshed out presentation deck. But here is the kicker, and this is what really got me. It doesn't just make those awful generic white slides with black text. It automatically matches your company's specific branding.
That is the magic touch right there.
It actively searches your corporate guidelines, grabs the exact approved fonts, utilizes the exact corporate hex colors, formats the headers correctly, the whole shebang. It builds a ready-to-present, beautifully branded deck from a single prompt, synthesizing the 20-page document into digestible visual points.
It saves countless hours of formatting.
So what does this all mean? Let's take a step back and look at the whole picture here. We have a system that is vastly smarter, beating its rivals by 144 points in complex reasoning. It has near-perfect recall over massive documents thanks to a 1 million token memory. It can operate as an autonomous team of parallel processing agents to troubleshoot its own problems. And it is plugged directly into the tools we use every single day, like Excel and PowerPoint, doing the heavy lifting of data cleaning and slide generation.
The capabilities are undeniable.
It is a genuine paradigm shift. But anytime we talk about an AI that is this powerful, this smart, and this autonomous, especially an AI that can write and execute its own code, we have to address the elephant in the room.
We do.
We have to talk about security, and we have to talk about cost.
It is the most critical conversation to have, and it is a conversation that often gets sidelined by the hype of new features.
So true.
As AI systems shift from passive tools that wait for our input to autonomous collaborators acting on our behalf and executing code independently, safety and alignment become paramount concerns.
Because the stakes are higher.
A highly capable system that goes off the rails is significantly more dangerous than a basic chatbot that hallucinates a recipe. The source material explicitly addresses this concern head-on, emphasizing Anthropic's core message regarding the development of Opus 4.6. They are adamant that these major exponential gains in intelligence and agentic capability did not come at the cost of safety.
Right, and to back that up with some specific metrics. Because safety is a very broad term. How are they actually measuring the safety of a model that is smart enough to plan its own multi-step workflows?
They look at a variety of metrics, but a major one highlighted in the source is the rate of deceptive behavior.
Deceptive behavior.
Yes. When models become highly advanced, there is a recognized risk in the machine learning community that the AI might learn to game the system.
Oh, like lying to pass a test.
Essentially, yes. To provide answers that the evaluator wants to hear while masking its true reasoning process or attempting to execute hidden commands.
That's terrifying.
It is a real concern. But they have backed their safety assertions with rigorous testing data. demonstrating that Opus 4.6 is just as well aligned as its predecessor, if not more so.
Okay, good.
Crucially, the testing shows extremely low rates of deceptive behavior, meaning the model is transparent in its reasoning and execution pathways. This is a vital metric in AI safety evaluations when models cross this threshold of advanced capability.
And what I found so refreshing about their approach to safety is that they managed to secure the model without turning it into a frustrating lockdown mess.
The usability is still there.
We've all experienced those incredibly annoying moments with older, safe AI models. You ask an AI a completely innocent, basic work question. Maybe you ask it to generate some dummy data for a database test or summarize a slightly controversial news article for a media report, and it throws up its hands and gives you that standard boilerplate response. I'm sorry, as an AI language model, I can't help with that.
This is maddening.
Its safety filters were too rigid, and it constantly misidentified benign tasks as malicious.
It is what the industry calls refusal friction. Overly aggressive safety tuning makes the model professionally useless because you spend more time trying to carefully phrase your prompt to bypass the paranoid filters than you do actually getting work done.
Exactly. You end up fighting with the tool. But the source points out that Anthropic has drastically reduced this friction for the end user. Opus 4.6 is actually less likely to refuse harmless requests than the older, less capable models.
They've tuned it much better.
They have smoothed out that user experience, which is a massive boost to workflow speed. You can just talk to it normally without walking on eggshells. But obviously, they didn't just turn the security off. If it can write its own code, it could theoretically write malware, right? How are they stopping that?
Yeah.
They're making it less restrictive.
They have paired that reduction in general user friction with highly targeted advanced security measures placed exactly where they are actually needed. It is a more nuanced approach to security.
How does that work?
The such details that Anthropic has built new, advanced probes specifically designed to detect potential misuse in highly sensitive, high-stakes areas. Cybersecurity is the prime example highlighted in the release.
Okay.
Because Opus 4.6 is so much more capable, especially in areas like agentic coding, where it can execute its own scripts, and in complex reasoning, where it can analyze network vulnerabilities, it is inherently a more potent tool for both defense and offense.
So if a malicious actor tries to use the agent teams to autonomously probe a company's server network for vulnerabilities and write an exploit script, these new probes are designed to catch that specific intent and shut it down.
Precisely. These specialized advanced probes act as a critical, localized safeguard. They monitor the execution pathways to ensure the model's advanced capabilities cannot be leveraged for malicious cyber activities, while still allowing the average user to ask standard questions without facing unwarranted refusals.
It is a much more sophisticated security architecture.
It balances power with safety beautifully.
Okay, so we know it's secure. We know the safety filters aren't going to drive us crazy. We know it is incredibly smart. And we know it integrates directly into our daily workflows in Excel and PowerPoint. So the final, most practical question for every single person listening to this right now is, when can you get your hands on it? And how much is this going to drain your company's IT budget?
Always the million-dollar question.
And honestly, this is the biggest surprise of the entire source material. Usually when a company releases a massive paradigm shift like this, it comes with a massive new enterprise price tag.
It is the standard industry playbook. You introduce a new tier of capability, and you introduce a new premium pricing tier to match.
But not this time. Opus 4.6 is available today, right now. As soon as you finish listening to this deep dive, you can go to the Claude.ai website and use it.
Incredible.
It is ready for developers on the API using that Claude Opus 4.6 ring we talked about, and it is already deployed across all the major cloud platforms. But the real kicker, the price.
This is the crazy part.
Despite these massive, industry-leading upgrades in intelligence, the 144-point lead over its rival, the 1 million token memory that actually works, and the entirely new parallel processing agent teams architecture, the cost to use Opus 4.6 is staying exactly the same as the previous version. Zero extra cost for a completely revolutionary upgrade to your capabilities.
This raises an important question for every professional, every manager, and every organization listening right now.
Oh, absolutely.
If a tool of this magnitude, a system capable of autonomous, multi-step problem solving and massive data synthesis, is made freely available at the exact same price point you were already paying, The barrier to entry for utilizing highly advanced AI has effectively vanished overnight.
It's totally gone.
You no longer need a massive enterprise budget to access top-tier intelligence. The competitive advantage in the marketplace will no longer belong to the companies who can afford to buy the best AI.
Who does it belong to then?
The advantage will belong entirely to the individuals and the organizations who can adapt their workflows the fastest to integrate these highly capable, universally accessible tools.
That is exactly right. The playing field hasn't just been leveled, it has totally shifted. If you are still using AI just to summarize emails, while your competitor is using agent teams to autonomously generate full market analyses in branded pitch decks, you're going to be left in the dust.
We won't be able to compete.
All right, to bring this all home and make sure you walk away with exactly what you need to know, let's rapidly summarize the 3 absolute most important takeaways from our deep dive today. These are the bottom line facts you need to remember and take back to your team. Number 1, unprecedented intelligence and memory.
The GDP Val benchmark.
Exactly. Opus 4.6 is now the definitive industry leader for complex knowledge work. It boasts a massive 144-point lead over GPT 5.2 on that rigorous GDP Val benchmark. And it backs up that reasoning power with an enormous 1 million token memory, roughly 750,000 words, that scored a 76% success rate in retrieving deeply buried single-fact needles from massive data pools, completely obliterating the previous model's 18.5% score.
Number 2, agent teams and true collaboration. The relationship with artificial intelligence has fundamentally shifted from a linear command and response tool to a parallel processing collaborator.
No more single chef in the kitchen.
Right. Through the 4 distinct stages of planning, execution, troubleshooting, and synthesis, the AI now autonomously coordinates multiple subagents to solve complex, multi-step problems with drastically less human intervention or hand-holding required.
And finally, number 3, everyday integration at 0 extra cost. These massive paradigm-shifting capabilities are not locked behind a developer terminal. They are being plugged straight into the tools you use every single day, like Excel for autonomous messy data structuring and PowerPoint for instant, brand-matched slide generation.
With strong security.
Yes, secured by advanced new cybersecurity probes that reduce friction for normal tasks while blocking malicious intent. And most importantly, the cost to access all of this remains exactly the same as the previous generation model. And it is available for you to use right now.
A truly massive update.
It really is. Now, before we sign off, I want to explicitly remind you to head over and check out the Tech News TLDR YouTube channel. While we love doing these deep dives here, we post daily video updates on the channel breaking down the fast-moving day-to-day tech landscape, so make sure you are subscribed over there so you never miss a beat on what is happening in the industry.
And as we wrap up this deep dive, I will leave you with one final thought to mull over as you digest all of this information today.
Leave them with something good.
We have spent the last hour discussing the sheer scale of these new capabilities. If an artificial intelligence can now independently plan a comprehensive project, dispatch a team of autonomous subagents to execute it, actively troubleshoot its own roadblocks in real time, and compile a final, highly polished, professional product, all with near-perfect recall over massive documents and at absolutely no extra cost to your enterprise, what exactly will define entry-level work in your specific industry by this time next year?
Wow. That is the question we all need to be asking ourselves and our teams tomorrow morning. Thank you so much for joining us on this deep dive into Opus 4.6. Stay curious, stay informed, and we will catch you on the next one.